All right, I called it 3-4B because we didn't quite finish last time. So let's get to it. I don't want to review everything that we talked about yesterday, but I will review just watch. You'll see. Let me grab this thing right here and put it right there. All right. So we talked yesterday. Remember we talked about that right triangle and Pythagorean theorem on how to find the distance of the hypotenuse? Yes? Okay, so it's kind of what we're going to do today. So let me do this. We'll do it in red again like we did yesterday. So I'm going to put a line, I don't know, let's just say right there. And I want to find the distance or the length of that line. That's what we're doing. When it says distance formula, we're trying to find the length of that line right there from this point to this point. And what they're going to be doing is they're going to be giving you a point. All right, whatever it is, negative, 7, 5, or whatever, okay? Whatever that point is. And then they're going to give you a point over here, whatever that is, like 5, negative 2. And then you got to find the distance between those 2 points. But we are not going to do it by graphing. Because remember we discussed yesterday, if you have a graph that's like really big, or points like negative 57 or 72 or 103 or something like that, that would be way too big to mark off on a graph and to count over and up and all that kind of stuff. So we need a formula, and that's what we're going to do today. So let me do this right here. Instead of calling this, whatever it is, negative 7, 5, instead of giving that an actual number, what I'm going to do is I'm going to call this x1, y1, because we're going to use these letters in our formula, okay? That's why we're putting x1 and y1, because in our formula, you're going to see this. This stands for any point, okay? Instead of just negative 7, 5, it could stand for any x and any y. Same thing for down here. Except I'm not going to call it x1, y1, because that would be the exact same point as this. What do you think I'm going to call this one down here? Very good. I'm going to call it x2 and y2. All right, so this is my first point. This is my second point. All right, this is my x and y for the first point. This is my x and y for the second point. Everybody with me so far? Now, what we did yesterday was this. I'm just going to use yellow. And it looks, where do you think? About right there? Does that match up with that? It's pretty close. I might be off a little bit, but that's okay. Did I use blue yesterday? Yeah. Okay, we'll try to go in the same color coordinate. Oh, yeah, it was pretty good. Okay. All right, so let's take a look at this. Let's go back to red. Now, yesterday, if you go back and look at the video, or if you took notes on this, okay, hopefully you have this right in front of you. Okay, you should have some notes on this. This point right here, I forget how far we went over and up yesterday, but this point right here, now you really have to think about this just a second. If you start at the origin, what is the x? We're not going to call it x3, y3, all right? Because we've already gone over this certain distance. How far to the left did we go to get to this point? Now, look at this. We didn't put any numbers. Okay, we haven't said any numbers. All right, look at that I circled right there. How far to the left have we gone to get there?
5, 2.
No, there's no numbers. No numbers. Say it. It's x1, right? Because look, how did we get to this point right here? We went over to the left, how far? x1. And then we went up, how far? y1. So again, I'm going to ask you, how far did we go over to get to that yellow line? We went over, we're not doing numbers. Okay, well, I was talking to Jake. All right, let's say this again. I want you to listen, okay? Nico, you're not listening if you turn around. So look at this point right here. How do I get to this point? I start at the origin, I go over this far, and then I go up this far. How far did I go over to the left before I went up to here? How far over? There's no numbers, okay? But remember, these things represent a number. Earlier I said, what if it was negative 7, 5? How far did I go over here? Negative 7, right? If it was. I'm just saying if. I'm just throwing out a number. Okay, I'm just throwing out a number. I don't know how far it is. So how far to the left did I go starting here? I went to here. How far is that? What is it? It's x1. You got it. Okay, it's x1. That's how far over to the left that we went. Because in order to get to this point, how far over to the left do you have to go? You got to go x1, and then how far up do you go? You go y1. So let's go back. How far to the left did we go? x1. Where is this point right here? How far over to the left did we have to go to get to this bottom point? How far over to the left did we have to go? x2's over here. Okay, now watch. I started here. How far over to the left did I have to go to get to this point? x1 again, all right? Because look, it's right under. This is directly under this point right here. So we went over the same exact distance to the left, didn't we? All right, what distance did we go to get to that yellow line? We went x1. So what's this point going to be? This is going to be x1. Okay? All right. I'm not going to worry about if you understand that part or not. Okay? I don't know how else to explain it. Now, how far down did we go to get to the blue line? Very good. Y2, because you're thinking, well, Y2's over here. But how far down did we go anywhere from the x-axis? How far down is it? It's x2. See this? Because we went over, I'm sorry, I said x2. I meant y2. I'm sorry about that. Okay, so you started here, you went over x2, and then how far did you go down? You went down y2. So look, this is the same distance down as this one is, isn't it? So if we went down y2 to get to here, guess what? We went down what? y2 to get to this. All right? All right. If you don't get that, it's really not that big of a deal. It's just so that you can see where we get our formula from. Now, with all that said, you remember we had that A, oops, there it goes again. Do that every day, don't I? There's an A and a B and a C. Do you remember that? Okay, because those are our two legs. The A and B are our two legs. The C is the hypotenuse. So what I want to do, and let's do this in yellow. We'll keep this color coordinated here. What I want to do is find the distance from this point up here down to this point down here. Okay, that yellow line. What's the distance of that yellow line? Let's say, now I know I don't have numbers here, but let's just pretend, like up here, look at my fingers up here. I'm looking up here. Let's say I'm at 7 right here, and I'm at 2 down here. What's the distance between 7 and 2? It's 5. How did you do that? What math did you do? You subtracted. You subtracted. That's the math that you did. You subtracted. But it's not a 7 and it's not a 2. How far on the y-axis, up and down, how far up are we? We're at y1. We're at y1, aren't we? How far down are we to get to that point? We're at y2. So, how do you find the distance between y1 and y2? The same way as we found the distance between 7 and 2, right? How do we find the distance? We do what? We subtract, that's right. So I could say y1 minus y2. Now the book does this. Instead of going y1 minus y2, they always go y2 minus y1. That's the distance of the yellow. That's how long the yellow distance is. Okay? Remember, if I was at the top, that would be 7. If I was at the bottom, that would be 2. What's the distance? It would be 5. What did we do? We subtracted, correct? So if the top is y1 and the bottom is y2, we just subtract. And it doesn't matter what order you subtract them in. Okay? You could go y1 minus y2, or you could go y2 minus y1. It doesn't matter. Let's do the same thing with the blue. Again, if you don't completely understand this, it's not that big of a deal. I'm just showing you how we get the formula, okay? So if you're looking at this, you're like, oh, Mr. Henry, I have no idea what you're talking about. That's fine, all right? But there are some in here that do kind of understand where we're getting this from. Let's do the blue one. So if I wanted to go from this point to this point, how do I find the length of it? How do I find how long it is from this point to this point along the blue? Rosalind? You got it right, okay? You just subtract the x's from each other, okay? So I would go x2 minus x1. That's how we find the length, right, of that blue line. We got the length of the yellow line. We got the length of the blue line. Now, remember yesterday what we had to find. We had to find the length of the red line, okay? And we did it. Now, remember, this is a right triangle. How did we do it? Once I knew what this was, and I knew, remember we had one, I think one of the triangles was one of the sides was 3, the other side was 4, correct? And then what did we do to it? We put it into a formula that we talked about yesterday. Or we didn't really call it we didn't call it a formula, but we called it a theorem, and that was the Pythagorean theorem. Remember that?
Yes, sir.
So what we're going to do now is this. This is like our A or our B, it doesn't matter which one you call it. This is our A or our B. This is our C. This is the hypotenuse, okay? Do you remember I also said that you could call it D for what? No, not diameter. It's not a circle. It's the distance, right? Okay, D for distance. So instead of calling it C because of the Pythagorean theorem, I'm just going to call it D. So here's what we're going to do. We're going to write D. Now, do you remember how to do the Pythagorean theorem? You square both of them, or you square all of them, right? And you add up the two legs and set it equal to the hypotenuse. So I go D squared equals. Now, what's my A in this situation? It could be either one. It could be this one, or it could be this one. Let's do the x's first, okay? So what did we do with the A? What did we do with that side on Pythagorean theorem? Do you remember Pythagorean theorem? It was c squared, kind of. We did it yesterday, okay? Less than 24 hours ago, we did this. And you should have it in your notes right in front of you. What is it? C squared equals what? A squared plus B squared. That should be right in your notes, okay? Well, it was on YouTube. If you took the quiz yesterday, if you weren't here yesterday, your responsibility was to watch the video on YouTube so that you're caught up with us. Shh. I didn't ask. Okay. So look, instead of C, we called it D for distance. You okay with that? That's not that big of a deal. Okay. Our A's and B's are the two legs. So let's do the X one first. This one right here. So what do we do with those? I square them, right? And so I just put it, Actually, it doesn't matter. Let's see. The book, what does the book do? It depends on which book. Yeah, I guess we could just do the x's. I think they do the x's. So it's x2 minus x1. That's the length of the blue one. And what's the length of the yellow one? It's y2 minus y1. This is one of the sides squared, right? Just like this. This is the other side squared. This is the hypotenuse squared. So we took this and we put it into Pythagorean theorem, and now we almost have our distance formula. I don't want what d squared is equal to. I want what d is equal to. Do you remember how to do this in, did we do this in here? One of my classes I did this. What if I said this? I think it was my college algebra class. What if I had x squared equals 9? Okay. What would I do to get x by itself? Did we do that in here? It seems like we did it in here. We didn't do it in here? Anyway, that's all right. That's all right, yeah. Ugh. Every day. Can you come in here one time and just stay in here the whole entire class period? Go. All right, Mike. Now, this is an x squared. This is not just a 2x. This is an x squared. It's different. You talking about this stuff here? No. Don't worry about this. Just over here. All I'm doing is going back. I just want to show you something, okay? So watch. I'm going to not ask you anymore. I'm just going to show you. So in order to get rid of a square, we take the square root. Anybody remember that? Okay, because you're doing the opposite. What's the opposite of squaring something? Taking the square root of it, okay? So if I take the square root of this side, then I also have to do what? Take the square root of this side. What happens to that square and that square root? They're opposites of each other, right? They're inverses of each other, so they cancel each other out. So I've got x equals whatever that is. Well, what is the square root of 9? You know what that is. What is that? Nobody? It's 3. Yeah, just 3. Okay. So the reason I went through that is because of this. I don't want d squared is equal to all this stuff. I want what d is equal to. So how do I get rid of this squared? I take the what? Square root. I take the square root. If I do that to the left side, I also have to what? Do it to the right side. So this is what it's going to be. So let's write it nice and neat. So d equals a big old square root, and then I put parentheses squared plus another parentheses squared. And remember, what is this? This is the length of the x, right? So how do I find the length of the x? I just subtract the two x's from each other. This is the length of the y's. How do I find that length? I subtract the y's from each other, okay? That right there is the distance formula, okay? So all that stuff that we talked about yesterday and the stuff that we talked about right now just to get to this. Now, do you have to know that on a test or a quiz as far as how we got to this? No, you don't. You do need to know this, though. Okay, what I got in a box right there, you have to know it. I will not put it on the quiz. I will not write it out for you. Okay, you must know this. All right, and you also have to know how to use it. And that's what we're going to do right now. Okay, I'm going to show you how to use it. To tell you the truth, it's a lot easier using it than coming up with it. All right. But I like, as a teacher, as a math teacher, I like to show people when I can't do this with every single theorem or every single formula that we do, but there are times where I think that you can handle figuring out where that formula comes from. And that's what I'm trying to do today. I just showed you where this comes from, okay? I'm not going to ask you to do all this stuff, this y1, y2, and x, or the x1, xy1, and x2, y2, and all that kind of stuff. I'm not going to ask you to do that on a test or a quiz and the stuff we did yesterday, but it all leads up to this thing right here, okay, that distance formula. So how in the world, what are we doing with this? Well, they're going to give you a problem that looks like this, all right? I only have one example here, but maybe we can do one of the problems in the homework together, okay, so that you kind of get a better idea how to do this. So this is example 1 in the book, and it says find the distance between, and then they're going to give you 2 points. And here are the 2 points, -2, 5, and 4, 1. Okay? So this is what they're going to ask. They're going to say, find the distance between those 2 points. Now, if you wanted to, I wouldn't do this, okay? But if you wanted to, you could plot the 2 points, right? You could go -2, 5, 1, 2, 3, 4, 5, right there. 4, 1, 1, 2, 3, 4, 1, right there. Connect them. Whoops, almost. Close enough. I'll make the dot bigger. All right, there we go. So what are we doing? We're finding how long that line segment is. That's what we're doing. So when they say find the distance between those 2 points, we're finding out how long that line segment is. That's what they're asking you to do. Okay? Does that make sense? You got to be able to visualize it. Because I tell you what, in this section 3, 4, there's 2 other things that we're going to learn. Okay? I'm taking this a little bit at a time. A lot of teachers would teach us all in one day, in one class period. Okay? I'm taking all 3 and I'm breaking them down into 1 per day, all right? Actually, 1 per 2 days, because I'm actually going to give you a worksheet on this after you do the stuff from the book, okay? Because I want to make sure that you're clear on this, because this is super important. You're going to see this a lot in math, no matter what math you take. So you got to know what you're actually doing here. You're finding the length or the distance between those 2 points, okay? So let's do it. Well, let's keep this up like that. And let's get rid of this. Okay. So here we go. Let's do some different color so it stands out from this. We got to put it in this formula. So what you have to realize is this is one of my points. This is my other point. Do you remember up here? This is one of the points right here, x1, y1. This is another point down here, x2, y2. So with that in mind, this point right here is going to be x1, y1. So I'm going to put an x1, y1 right there. What's this point going to be? This is going to be x what? 2 and y2. All right? So that should help us with this formula. Now all we got to do is stick these numbers into this formula and then just do some math and work it out. Okay? Does that make sense? So the one point is the x1 and the y1. The other point is the x2 right here and the y2 right there. So we just plug them in. So let's write out our formula. So distance equals, put d equals, big old square root. And what I would do for every single one of these problems, I would write out the distance formula every single time. Why would I want you to do that? Why can't you just stick it at the top of your paper so you can remember it exactly right? You could just put it at the top of your paper, or you could just refer to your notes. But if you write it down every single time, by the time you get to the last one, you'll have it memorized just like that. Okay? You will have to memorize this. Everybody hear me on this? Let's write it down. Okay? You need to memorize this right here. Okay? There's no way around it. You have to know it. I'm not going to tell it to you on a test or a quiz. So, here's how I do it. I put the big old square root, and then I put the parentheses and the squared, put a plus in between. I call this the shell of the formula, or the, this is a formula, distance formula. Okay, I call it the shell because I really haven't stuck anything in there yet, okay? It's always going to look like this. It's always going to be like that. It's kind of like our template, I guess, or whatever. I call it the shell of the formula. Now, what goes in here? What do I do in here? Well, what does it say? I subtract the what from each other? Subtract the x's from each other. So which ones are our x's? Well, the first one, right? This one and this one. Now, it doesn't matter what order you subtract them in. Okay, I said that earlier, right? I could have made this x1 minus x2, but the books always put the 2 first. I don't know why, but they do. But I could just subtract the x's from each other. So let's do it the way they told us. x2 minus x1. So what is it going to be? 4 minus, a lot of people say 4 minus 2, but it's not 4 minus 2. What is this x? This is a what? This is a negative 2. So it's 4 minus negative 2. All right? And almost every time I ever teach this, somebody would say 4 minus 2. So, you're in good company because everybody says that. But you got to look at what the signs are. This is a 4. This is a minus 2. You subtract them. It's 4 minus negative 2. John.
I got it.
Go ahead.
So I get like the negative 2 is on the negative side of the graph, but can't distance not be negative?
Yeah, but look what you're going to do to this. Well, this isn't going to be negative anyway because 4 minus negative 2 is going to come out positive. Right? Minus a negative is positive, right? Add the opposite. But even if it did come out negative, what are you doing to it? You're squaring it. So when you square a negative, you always get a what? A positive. Because 2 negatives multiplied together is always positive, right? So that's why it doesn't matter what order you subtract them in. I could have gone negative 2 minus 4. That would give me a negative 6, right? And you're right, you can't have a negative distance. But what are you doing to it? You're squaring it anyway, so you're going to get 36 no matter how you do it. Make sense? Okay. So let's do the other one. Now we're going to subtract the y's. So we subtracted the x's. Now we're going to subtract the y's. So, and again, it doesn't matter what order you subtract them in. But let's do it the way the book tells us to do it. Let's go to the second one minus the first one. Okay, so the second one is what? The second y. It's 1. Whoops, there we go again. Let's try this again. It's 1 minus what? 5. Okay, remember, the y's. You got to only subtract the y's from each other. So 1 minus 5. This will come out negative. 1 minus 5 is negative 4, right? It will come out negative, but when you square it, squaring anything always makes it positive. All right, so it doesn't matter what order you subtract them. All right, now we're ready to just work it out. Let's do all the stuff in the parentheses first. Okay, remember order of operations? Please excuse my dear Aunt Sally. Do parentheses first, then you do exponents, right? Then you can add and subtract. All right, that's exactly what we're doing here. So 4 minus negative 2, do you remember that? Add a line, change the sign, right, for subtraction. So what is that? That is 6. And what are you doing to that 6? You're squaring it. That's not hard, is it? Very simple. Okay, put a plus down. What's this? 1 minus 5. What's 1 minus 5? It's negative 4. Remember, add a line, change the sign. When you're adding two different signs, you subtract them, take the sign of the bigger number. So that's negative 4. But let's keep it in parentheses since we've got a negative there. What are you doing to that negative 4? You're squaring it, aren't you? Okay. We're getting close. We're almost done. Let's figure out what this stuff is. Let's do the square stuff now. Let's do the exponents. Man, I knocked about half you guys out. Is it that bad? Come on. Man, this is new stuff. All right? You got to stay awake. I know you got the itis from lunch, right? You guys ever say that? My kids always used to say that when after you eat a lot and you get real tired and you're like, oh, they always said you got the itis. So that's how I always said it. So watch, 6 squared is what? 36. Plus, what's this? Is it negative or is it positive? It's positive because when you square a negative, it's always positive. All right? And that's 16. You with me? Now what do? We did the parentheses. We did the exponents. Now we can do what? Add them together. It's still under a square root though, isn't it? All right? What's 36 and 16? It's 52. All right? Now, what they're going to want you to do is get a decimal answer for this. How in the world am I going to get a decimal answer for this? What am I going to use? Use a calculator. Okay? Just happen to have a calculator here. So let's put it in. We talked about this yesterday, didn't we? Didn't we do the calculator thing yesterday? Was it in here? I can't remember. So I hit the second function. I hit this button right here, which makes a square root. Okay, it's 52, so I put 5, 2. And then you could close the parentheses if you want. You don't have to. Then I hit enter, and then that's what it is. And it looks like they just rounded to the first decimal place. Now watch very carefully. I'm not going to mark off if you don't do this, but as a math teacher, I feel obligated to make sure I do this. I put a little squiggly equal sign, approximately equal to, because this thing, it would keep on going forever and ever. All right? And it's not exactly 7.2, is it? Because you got all that stuff after it. So it's approximately 7.2. How do I know it's 0.2? Why don't I round it up to a 3? Yeah, because the number after it is a 1. When would I round it up to a 3? When it's 5 or over, right? When it's 5 or over, if it was 2.5, if it was 0.25, then I would round it to a 3. All right? Everybody with me on that? So I don't care about any of the numbers after that. I just care about that one right to the right of it, and it's 1, so I don't round it up, and that would be the answer in the book. So if you flip to the back of the book for the odd problems, you would see your answer looking like this. Okay? Let's do one more. Let's do one from the book. Let's do like the first one. Somebody tell me what the points are. What page is that? Should be page 132. Does anybody have the book open to page 132? It's, number 1. What is it? 6, 4, and 2, 1? Okay. 6, 4, and 2, 1. Again, what are we doing to these 2 points right here? We're finding the what? The distance, okay? Tell you what, I'll give you about 30 seconds. Ready? Go. Find the distance. Don't just look in the back and write down the answer, okay? Find the distance. You're finding the distance between these 2 points. Just do it right there in your notes. You're going to have to do it tonight anyway for homework.
Just a reminder, JV and varsity volleyball, you have a dismissal now. You will be leaving at 1:45 from the lobby. Thank you.
Again, what I would do, I would write the formula every single time. Okay, so let's do that first. Okay? Remember what it was? X2 minus X1, Y2 minus Y1. Okay, so you wrote the formula. Now, let's plug the numbers into the formula. So I'm going to put that big old square root right there. I'm going to write the shell of my formula. Because you know you're going to do that every single time, right? So now what we're going to do is we're going to subtract the x's. Which ones up here are the x's? Well, they're the first ones, right? The first ones in the ordered pair. So 6 and 2. So I subtract the x's from each other. It's really easy once you know what to plug in. And then now I subtract the y's from each other. Which ones are the y's? The second part of the ordered pair. So it's the 4 and the 1. You got to do that part right first, okay? You got to get that right. If you don't put the right numbers in, there's no way you're going to get the right answer unless something wacky happened and I don't know. So watch. Do this. So what's going to be inside of here? 4. And what do we do with that 4? Square it. Put a plus. Now we do this thing right here. 4 minus 1 is 3, and we square that. See how easy it is? It's not hard. It's not hard at all. Put it. So watch. Well, they are right. So watch. What's 4 squared? 16. Plus 3 squared? It's 9. Let's keep going. I'm writing every little step down, okay? What's 16 plus 9? 25. Now, look at this. I don't even have to put that in my calculator because I know what that is. And I don't even have to put a little squiggly equal sign. Why don't I write approximately? Because you know exactly what it is. That's right. You know exactly what it is. What is the square root of 25? It's 5. So, that's what it is. Okay? Right. They went right to the answer, and he was going from here to here. He was not wrong. He was just telling us the next step, and that's what I was asking for. So that's how you do it. That's number 1 on the homework. I just did it for you. Okay? So now you only have 5 problems to do. How easy is that? All right, listen to me. Listen to me. Hey, you have 10 minutes left. You have 5 problems to do. So all you math majors, how many minutes per problem? 5 minutes per problem.
No, 2.
How about 2? Okay. So you have 10 minutes. All right, so let's get it done. 2 minutes per problem. You should be able to get this thing done, okay? So you're doing 1 through 6, page, what did I say was 132? And it's section 3, 4. Let's put A. Everybody watch this. On the top of your paper, put 3-4A because this is the first assignment on 3-4. I'm going to give you at least 3 assignments on 3-4, okay? This will be the first one. We'll call it A. So that is your homework.